Hi everyone, we're for SED students from Sustainable Environmental Design. My name's Olivia, and we wanted to share a little bit of the work we've been doing for the last year. Like, we deal with climate and climate analysis constantly in our program, and we understand like the approach to the design is by understanding like the place specific needs culturally and climatically. So we're going to show a little bit of our term one project that we worked in Hook Park, retrofitting a building there. Then on the second term, we worked on a design from scratch. And then we're going to see Hara's dissertation project. So yeah, welcome.
Okay, hello, my name is Hara, and I will start with a question. Taking into account the climatic crisis and the Anthropocene era, a major question arises regarding architecture. How do we architect if climate matters? In the SED postgraduate program, dealing with the climate is one of the most significant aspects. This is something to be better understood through our examples from the work as SED students. The place. During term 1 and term 2, we studied Hook Park Forest. In term 1, we studied several of the existing buildings of the campus, their performance and proposed ways to ameliorate these shells. In this presentation, the Fry Autos building, the workshop, which my team analyzed, is presented. In term 2, each team proposed a holistic vision for a new building to house future needs of the campus. Main goal for us was to create environmental-friendly spaces of a small footprint, after studying thoroughly the climate of the topos. In today's presentation, my team's vision for a housing sim for visiting students is presented. And now comes the question, how architecture can be climate responsive? According to Simos Giannas, the SED program is a combination of experience, analysis, experiment, and interpretation. This method is followed in order to interpret and transcribe environmental and climatic aspects of a specific context into an architectural composition. Studying at the Hook Park buildings, as if Hook Park was an open laboratory, gave us some important lessons on how to approach environmental architecture. One important thing is the way we approach simulation tools. I want to talk about this because, unfortunately, sometimes our environmental architecture is reduced to its technical aspect. The computation programs are tools, and the results are calibrated and interpreted with critical thinking, referencing both the spatial experience and the measurements. This is why fieldwork is intertwined with simulations for us, and experience is irreplaceable. Observing and experiencing the environment as if we are a sensor and can make us decrypt hidden mechanisms and functions behind space. This experience, combined with measured data and analytical insights, can deepen our understanding on how a building's form performs within a specific climate and environment. For example, the workshop features a protected inner cavity shielded by a large curved dome roof. The roof openings are designed to maximize solar gain for thermal efficiency in winter, while in summer they support cooling through strategic ventilation using the Venturi effect, buoyancy, and cross-ventilation principles. Term 2 synthetic project initiates from the nucleus of a site-specific central idea. This is related to place, climate, and people. Every place on Earth is characterized by a duality, the environment, which includes the topography, anaglyph, and climate, but every place on Earth is a microclimatic environment, a system of increased complexity. A number of parameters co-shape it: orientation, sun, land, surroundings, vegetation, heavens. In order to design for the climate, simulations serve as a tool for understanding natural phenomena and energy exchanges within and around the built environment. For example, using the Mintsoft computational tool, we could check the impact of the building shell in the different seasons together with the presence of people and appliances for all different evolutionary stages. Environmental design aims to understand natural phenomena and to integrate them thoughtfully into a unified architectural concept. For example, the transitional spaces, such as thresholds or conservatories, serve dual roles, functioning as architectural features and as thermal buffers to help regulate indoor temperatures. This approach to architectural methodology is important in that it allows for architecture in harmony with the environment, climate, and people in the Anthropocene era. Environmental architecture should not arise by chance. It starts from an architectural idea and expands to the environment. Performance control, geometrization, and synthesis of architectural elements allow the harmonious coexistence with the environment. People as a dynamic entity can affect in various ways their environment. When we carried out with my team the thermal behavior control of our building proposal, it was essential to define the occupancy patterns. That is, that we had to imagine how our space is inhabited and to evaluate the impact of human presence using schedules in the specialized software of Energy Plus thermal modeling. This method, from my point of view, can lead to a symbiosis under the triptych of human, environment, and climate. And it is something that can and needs to be implemented. And now it's about applicability methods, the second part of the presentation. And in this chapter of the presentation, 2 examples of this year's MSc project are discussed. Both projects address the concept of applicability in hot climates. The 2 theses presented show a way to approach different climates and contexts with the aim to create comfortable outdoor and indoor living spaces. The criteria for more comfortable spaces are not merely technical, but deal with the inner substance of architecture and tectonics, addressing urban, social, pragmatic, and existential issues. Outdoor living in Athens. Motivation for this thesis was the problem of the degradation of outdoor living in Athens, together with the latent potential of the city because of its dynamic formulation. Athens is the capital and the largest city in Greece. The urban morphology of Athens resembles a contemporary vernacular settlement containing its own typologies of habitation and life formulation. It is characterized by narrow streets, dense urban mass, and white colors. Due to Athens' unique geomorphology, topography, and geographic position, it exhibits its own distinct climate. Athens' climate is classified as Mediterranean, characterized by hot and dry summers and mild, humid winters. Sun, wind, materialities, and urban morphology can affect the outdoor comfort in the city. The future climate trends for Athens are also examined to ensure that design solutions extend into the future. In this slide, UTCI heat maps with sun and wind as variables are presented, highlighting that summers are the major problem of outdoor living in Athens. The intensity and duration of hot and dry summers will double in future scenarios for 2070. This shows that shading and ventilation can be crucial as climate mitigation practices for outdoor comfort. Fieldwork, experience, and analysis of the context can reveal successful solutions from the city for the city. For example, the study of a path with a multitude of typologies for outdoor spaces can lead to a taxonomy of spaces both in terms of types and in terms of comfort and microclimates. Solar and wind exposure scale of privacy, people's preference, and spatial potential vary significantly between spatial typologies. The openness of a square is a very different environment from the protected cavity of a store. The UTCI index for outdoor comfort can help to compare the different sense of comfort people experience across the multiple urban typologies. This sense of temperature can change drastically, even if the measured temperature is virtually the same. Materialities and colors of the urban fabric can modify the environmental conditions of a place, especially if those are exposed to direct sun. Here, the analysis of two exemplary repeated patterns of the fabric can show how orientation, density, and green areas can affect the outdoor comfort of different areas in the city center. The compact urban mass with the small streets protects the streets from excessive solar radiation, but also blocks the wind. Shading and ventilation are the two main strategies to achieve the outdoor comfort in this urban environment. UTCI studies for the two neighborhoods highlight the outdoor thermal comfort. After examining the Athenian city, a toolbox is proposed for understanding and creatively handling the city. This includes both the synthetic tools and the instructions for their use in specific contexts and seasonal variations, essentially a manual or guidelines. Urban typologies, as identified through fieldwork and analysis, are defined as tools. These typologies are more archetypal in nature, as they have been found in the same form for many centuries. Solar and wind exposure can vary based on their inherent spatial characteristics. In this case study example, the previous proposal for a toolbox is applied, starting from a central idea defined for this specific environment after understanding the genius loci. In these UTCI maps, environmental parameters tested include materiality, shading, placement of deciduous trees, and portico. Indoor living in Cyprus. Motivation for this thesis was the degradation of the refugee settlements and the social aspect of environmental architecture. The displacement of the Greek Cypriots in 1974 to the southwestern side of Cyprus created a significant housing need, leading to the gradual establishment of 69 settlements in the 5 districts of the island. The issue of the refugees and the invasion remains the most important issue for the country. Cyprus is located in the eastern Mediterranean region. The island's climate is subtropical with a combination of hot semi-arid and hot summer Mediterranean. It is characterized by long, hot and dry summers and mild winters. The main challenges of Cyprus climate are intense solar radiation, high temperatures, ventilation, high relative humidity. The potentials behind those problems are shading, efficient building envelope, semi-outdoor spaces, and solar energy. The vernacular architecture of the region and the Mediterranean in general is characterized by elements that help adapt the building to the location and climate. Through passive practices such as iliacos, they managed to construct buildings with thermal comfort inside the building as well as in semi-outdoor spaces. The large number of settlements in different areas of Cyprus has created difficulties in analyzing the entire set. For this reason, the pilot settlement is selected. The diagrams analyze the built and unbuilt environment of the settlements, identifying urban fabric motifs. The study continues with the analysis of different microclimates. It is important to note that the results of the fieldwork provide the foundation for the improvements that will be implemented as they facilitate quick, targeted decision-making. The improvement proposals for the settlements have two main goals. The first is to enhance the quality of life for residents by addressing the various needs. And the second is to improve both indoor and outdoor through specific environmental retrofit guidelines. The airflow analysis in base case shows the improvement is needed. The improvement will target cross and stack ventilation, as well as achieving night ventilation to remove hot air during the evening. For the effective implementation of passive cooling, several shading systems are being studied, with adaptability being the key criterion. The implementation of the awning added on balconies in the apartment building is studied as part of the system for adaptable shading. Completing the adjustments, a study of the incident solar radiation on the windows of the building was conducted to assess the facades together with the possibilities. This resulted in a reduction of the incident solar radiation of 80%. The addition of balconies and an elevator introduces several potentials to the residential buildings. Beyond addressing the immediate needs of the residents, it also brings environmental benefits by protecting the building envelope. This building upgrade has a human element, as it establishes intermediary spaces where residents can spend more time. Moreover, the possibility of future floor expansions is facilitated by the new access corridor and the elevator extending to the rooftop level. The entire study reflects a holistic architectural vision aimed at improving the quality of life for refugees through environmental practices that address every corner of the settlements. Thank you. So now we have some time for Q&A, if any of you has something.
We'll offer a comment first and then open the microphone to the floor if anyone.
Yeah, thank you for that fascinating study. I was following it all the way through in the way that you've deconstructed the elements and the way that you resynthesized through a kind of body-based experience of the city, as well as looking at the kind of environmental challenges. I guess the question I have really about this is one for you, really, which is about the static nature of architecture. It seems that the kinds of interventions you're thinking about are changing through the day, whether you're extending an awning or whether you're adjusting shading or whether you're opening vents to get cross circulation or changing the heat capacity at night, those kinds of things. A lot of the, let's say, smart homes that we're starting to see, where much of this stuff is automated. I'm kind of thinking of a synthesis here that's between a kind of an automated smart, where a machine does this on program through sensors, and the value of having a kind of person-based, culturally sensitive, site-specific set of moves that you do during the day. I'm just from your studies, really. I'd just very much like to hear the work that people have to put in to maintain this degree of comfort that the modern home has promised to kind of take away as a form of work. Just interested.
Okay, thank you for your comment. I think it's more based on understanding your own body and your needs. And also, for example, we try to put mechanisms that you can easily use, for example, an adaptable system, so that it's not everything automated, or if you have something automated, it's more based on your schedule, on how you use the space.
Yeah, if I can add something to that, I think it's the dangerous thing about the automated system is like sometimes everybody has their own needs and we perceive what's comfort very different. And kind of taking away the choice, like being able to intervene yourself according to how you feel. I think that's something we should be really careful when we look to automated systems. We see it in the office nowadays. It's like, okay, you cannot open the windows because everything it's perceiving, it's so technical. But what if people like, it's also, there's a sense of breathe that you feel when you open the window, or at least having the choice and the possibility to choose kind of gives the body a certain openness to already feeling more comfortable, knowing that you can have an impact on how you adapt the environment to you. So I don't know if...
Okay, I'd like to respond to that because in some ways that's the conventional view of technology, particularly of dynamic things. But in very recent years, that's been entirely reconceptualized, not as mechanical systems like we have here, but a much more arrangements of material that in themselves change their geometry as heat increases or humidity changes.
Oh, absolutely, yeah.
Okay. So I think those kind of, I think the project is great, by the way, and we're just going on with this. What happens? You're sitting here in 40 years' time trying to explain to students what it is they have to do, and you mentioned the whole of the Mediterranean, but particularly Greece and Cyprus, are facing very, very profound changes over the next 30 to 50 years. So there's a kind of open thinking that has to come on both on the sensing and the dynamics of architecture, of how we can do that. And I think some of it is also going to be reimagining the way people live. So one of the worst scenarios is always to do with the inability to sleep at night with very high humidity and high temperatures. But still traditionally, people sleep upstairs and live downstairs. So the kind of architectural reconfiguration or rethinking of spaces, I think, is an important dialogue for the future. Can anyone else like to? No?
I just also comment. I think there's an issue of ability in this as well, which is, there are able-bodied people that are young, that can pull down an awnings, and that they can move up and down the stairs. And then there's a group of people that aren't so able. And I guess, again, kind of like enfolding the rituals of daily living into something that kind of sits between maybe a spectrum of comfort, because let's say maybe the young body can tolerate more extremes of discomfort than an older body. And then there is and then there's the other part of it, which is about clothing and portables, like the degree of layers now that we wrap around ourselves. Because let's say a conventional building in modern times has a certain number of layers, right? But then if we need, so first of all, we might think of clothing, then we might think of hats, then we might think of umbrellas, then we might actually bring around a portable tent, I guess I'm thinking about inviting you to think about the layers of wrapping around us. How many of those are fixed? Because those were the ones that you mostly kind of commented on. And how much work does the body have to do to stay comfortable in its space? I don't think there's any easy solution to it, but I'm just trying to get you to think, because you've really started to unpack something very interesting here about how do we become extremophiles.
Thank you.
Thank you. Thank you, Hara and Olivia. Yes, I think that's a recurrent issue about the automated or the more personal way of controlling our environments. I think that what Hara tried to communicate here was about providing choices, and in particular to the type of buildings that she presented, which are quite either housing or teaching and learning environments. It's true that, especially now that we are becoming more and more international cultures and people are traveling everywhere and we all feel differently, I think it's fascinating to allow this choice because, as you were saying, not only age, but the clothing layers and so on, we all feel differently. And just to tell you that before coming here to London, I lived many years in an automated office building in Brussels. And it was a rounded building, and every time it was sensitive to the solar radiation, and every time at a certain time, the awning started to roll down automatically, and we would all jump to stop the system because we didn't want this to be shut. So allowing this flexibility. In some environments, you want the automated to be working because it's more helpful, but also allowing certain control. I think it's a very necessary aspect. But yeah, I think, thank you.
I think it will be extremely, like the challenge would be in the future, how can we kind of merge these two worlds where we have an automated system but with a personalized understanding, like, or if it's a matter of choice, like the average of how many people would like the owning or not. But yeah, that's...
But I think it needs, in order to reinvent automated systems, it needs you to be part of the reinvention. And I think that's the real issue, that I think it's great that you have this, profound knowledge developed in the program over decades of what you can do with vernacular architectures. But I suspect that changes that are coming in the climate are so profound, and particularly in the Mediterranean, that there's a kind of limitation that we'll have to invent a new way of transcending that.
Yeah.
And like in all building materials,
I think
if you just wait for the manufacturer to develop a new material, they're just not going to. It's all invested. There's the economics, they're making money, why should they change? It's only pressure from you. As environmental specialists and engineers, it's only pressure from you that's going to, lead to those changes. And experiments too. So I think that's also in the longer tradition of School of Tropical Architecture in the EAA and then SED, those kind of material spatial experimentation is really a crucial dimension that we need to not just recover, but enjoy exploration through that. So.
I think some answers are already there in the vernacular, as you said, but we have to just observe and be human animals, meaning sensors ourselves, because we stopped to understand how we use spaces. That we will go to a store if it's too extremely, the sun is too extreme, that we will do things by our own without somebody telling us do that. It's about freedom.
Because I think one of the things that's happening that isn't addressed by the vernacular are the extremes and the frequency at which we're encountering them. And so quite notably from the Athens scenario, it didn't see wildfire or, smoke, coming from sections of the land that's on fire. And it's, and if we think about Valencia, this week, it is the sudden nature, the kind of the traditions for adaptation that we have been used to, including moving somewhere else, have been very compromised by the severity of these environmental changes. And I think that's the kind of the flashpoint for us. And I think Mike's right, that in some ways we need to anticipate what we need. and not wait until, yet another disaster strikes and then we start thinking about, oh, well, we should have made that little round tin floating capsule because that would have been very handy.
I think in Athens, the geomorphology helps, though, to have ventilation because there is the north air that runs through the territory. So when you have a fire, then it clears very quickly. But the fire is a problem itself.
Right.
Yeah.
Okay. Any last comments from anyone? Lots of smiles, so thank you very much.
Thank you.